Hello, I'm Gordon Cooper. Let's talk about deep learning in the context of embedded vision and how it works. Deep learning, which is a mathematical way to model or make sense of abstract data, is quickly becoming a requirement for embedded vision processors. It offers better accuracy than traditional vision processing algorithms for image detection, recognition, and classification tasks. To help explain how machines can use deep learning, let's use the analogy of teaching a young child to recognize an object, say a cat. To teach a child to recognize a cat, you start by showing her pictures of cats while explaining what's in the picture. As the child's brain processes the images, it begins to form an impression of what a cat is. This is called a training phase. Soon the child can use the knowledge gained to see a cat in the real world and infer that it's a cat. Training a machine to recognize objects also requires two distinct steps: training and inference. To keep with our analogy, our machine's brain is a neural network, really a bunch of nodes that have to perform multiple accumulation operations and store the results in a memory location. Our machine's brain starts out untrained. Deep learning training for a machine is done on a high-end computer. Labeled images of cats are fed into a neural network, which breaks the images down using convolutions, and the neural network learns by adjusting the weights or coefficients with each iteration. After many images and even more computations to obtain a set of well-trained and validated coefficients, the graphs and weights are transferred from the computer into the machine, in our case, an embedded vision processor, which can be optimized for performance and low power. Then, when images come through the camera lens to the image sensor, they are processed in the embedded vision processor that has been configured with the trained graphs and weights. If a cat is in the field of view, the convolutional neural network will return a result that it has seen a cat. This processing is no small feat. It takes a lot of horsepower to execute the algorithms on the embedded system in real time and using minimal power. It's possible only thanks to technological advances in the past few years, including more transistors on smaller die and more compact and efficient algorithms. Deep learning in embedded vision can be used to enable digital cameras to detect faces, automobiles to identify signs, pedestrians, and other objects to avoid, and surveillance cameras to spot intruders, animals, and other activity. Synopsys DesignWare EV6X embedded vision processors are built specifically to execute the complex tasks required for fast, low-power vision processing. The EV6X processors are helping designers maximize their design's performance while minimizing power and area. To learn more about embedded vision, please visit synopsys.com/EV. Thanks for watching.